Hello friends, welcome back to my YouTube channel. In this class, I am going to discuss all important topic of entropy principle, or which is also called principle of increase of entropy. But before that, we must discuss about how to calculate the entropy change of a closed system undergoing an internally irreversible process. Before starting, I must say one thing to all of you. Please do subscribe to this channel. Of course, like it and share it to your friends. Let's get started. See, suppose this is a property diagram. Y is this is x-axis. It represents one property, and it is y-axis represents another property. And suppose a system travels from state 1 to state 2, state 1 to state 2, following an internally reversible path A, and then it comes back from state 2 to state 1, from state 2 to state 1, following another internally reversible path B. And this is of course a closed system. So we are now going to calculate the entropy change of a closed system. So this is a closed system, first undergoes a process 1A2, and which that process is followed by another internally reversible process. Always on any property diagram, full lines, solid lines represent reversible processes, and the dotted line represents irreversible process. Suppose from state 2 to state 1, the system can also travel through another process which is an internally irreversible process. This is suppose process C. This is 2C1 is an internally irreversible process, but 2B1 is an internally reversible process. And you see these two processes A and B together constitute a reversible cycle or internally reversible cycle. That is 1A2 B1 is internally reversible cycle. Internally reversible cycle, because this cycle consists of two processes which are internally reversible, A and B. But if you consider about the cycle 1A2 C1, this will be an internally irreversible cycle. Whenever a cycle consists of all the reversible processes, then that cycle is a reversible cycle or internally reversible cycle. And if any of the process constituting the cycle is an irreversible process, then the cycle is called an irreversible cycle. So you see, according to Clausius inequality, which we have already studied, according to Clausius inequality, cyclic integral of del q by t is less than or equal to 0. In fact, this less than sign is applicable for irreversible cycle, and this equal to sign is applicable for reversible cycle. So first, for the cycle 1A to B1, this is a cycle 1A to B1, this is a reversible cycle. So for this cycle, we can write cyclic integral of del q by t equal to 0. You know, cyclic integral of del q by t is nothing but the summation of the del q by t calculated along the various paths that constitute the cycle. So this means I can write del q by t evaluated along the path 1a2 plus del q by t evaluated along the path 2b1. This is equal to 0. This is equal to 0. Suppose this is equation A. This is equation A, suppose. And for the cycle, that is internally reversible cycle 1A2C1, if you apply the Clausius inequality, that will be like this. For cycle 1A2C1, you see in this cycle 1A2 is reversible process 1A2, but 2C1 is an internally irreversible process. If any one of the processes that constitute a cycle is irreversible, means that cycle will be called an irreversible cycle. So this is an irreversible cycle, and if you apply Clausius inequality, that will be cyclic integral of del q by t will be less than 0 for this cycle, irreversible cycle. And if this integral is replaced by addition of two terms, then this will be del q by t 1a2. Two paths are there, so two integrations are to be carried out. Del q by t 2C1, which is a irreversible process. An irreversible process 2C1 is less than 0. This is suppose equation B. From equations A and B, we get from equations A and B, if you consider these two equations, I can write equation B like this. That is del q by t 1a2 plus del q by t 2c1 is less than, suppose in place of 0 I will write this equation A, because this plus this is equal to 0. So in equation B, if I substitute equation A, I will get, in place of 0 I will write the left hand side terms of equation A. There is no problem in it. In place of 0 I will write del q by t 1a2 plus del q by t 2b1, and this comes from equation A only. Del q by t plus del q by t 1a2, this 2b1 is equal to 0. So this is again suppose equation C. So you see, this is the inequality that comes out finally, and cancelling these two terms on both sides, you see del q by integral of del q by t 1a2 is present on the left hand side, and this is also present, the same term is also present on the right hand side of the inequality. So we can cancel out these terms. So these two terms are cancelled. Now this inequality results in so you see, this we can write down as del q by t. This 2c1 is an internally irreversible process. Internally irreversible is less than integral of del q by t. This is internally reversible process. between two given states, if you evaluate this integral, always this the integral evaluated along the irreversible process will be less than the integral evaluated along the reversible process between two same end states. So because you see on the diagram, property diagram, 2b1 is a reversible process and 2c1 is the irreversible process. So you see, but we have already discussed that for a reversible process, delta S is equal to integral of del Q by T. We have already discussed that. The entropy change of a closed system during a reversible process is nothing but the integral of del Q by T evaluated along that process. Reversible process के लिए integral of del Q by T, or you can say integral of d cut Q by T, is nothing but delta S, that is change in property. So I can write this inequality like this: delta Q by T internally irreversible process is less than delta S, less than delta S, change in entropy, change in entropy. So you see, I can write down like this. From this I can write delta S is greater than integral of del Q by T internally irreversible process. So in other words, entropy change, I can write like this: entropy change for a closed system, for a closed system undergoing internally reversible process, irreversible process is greater than entropy transfer. You know, this term integral of del Q by T always represents the entropy transfer. You know, entropy transfer takes place whenever heat transfer takes place between the system and surroundings. And when heat is added to a system, entropy transfer is positive. That means entropy is transferred into the system. And when heat is rejected by the system to the surroundings, entropy transfer is negative. That is, there is a transfer of entropy from the system to the surroundings. So greater than the entropy transfer is always calculated by integrating del Q by T over the reversible process between two end states. So that is the entropy transfer. And if that particular process is irreversible, then if you calculate the change in entropy between two end states, it will always be greater than del Q by T, integral of del Q by T evaluated along the irreversible path. And this is equal to the integration evaluated along the reversible path. So irreversible process के लिए entropy change for a closed system, of course, is always greater than the entropy transfer. That is integral of del Q by T evaluated along irreversible path, evaluated along the process. So evaluated along the process. So that means delta S means, of course, this is capital S. Delta S is greater than integral of del Q by T for irreversible process. And you see, that means delta S is equal to integral of del q by t plus something. Since this is greater than this means this equal to this plus something. Suppose this is x and this x is always positive. This x is always positive. Since delta s is greater than integral of del q by t for an irreversible process. This one is for irreversible process. This relation is valid for only when a irreversible process takes place by a closed system. So delta s is equal to integral of del q by t plus x. So what is, and this term is going to be positive always because this is greater than this. So this term is nothing but, this is called entropy generation. Entropy generation, or you can say sgen, entropy generation or entropy production. Entropy generation or entropy production. And if this process had been reversible, then this term would have been absent. This was not there. If the process is irreversible, then only this x comes into picture, and it is always positive for irreversible process. But for reversible process, we know that relation is nothing but delta s is equal to integral of del q by t. For a reversible process, delta s is equal to integral of del q by t. There is no other term present, but for irreversible process additional term is there, which is entropy generation. So you see, entropy generation is present only for irreversible process. For reversible process undergone by any system, no entropy generation is there. Entropy is produced during a process only because of the irreversibilities or losses like friction, surface tension, etc. So that's why the entropy generation is dependent on the process. It is not a property or point function, it is a path function, because for reversible process this is 0 and for irreversible process it is always positive. And you see, entropy generation can never be negative, can never be negative. ये negative हो नहीं सकता. Entropy generation is always either positive or 0, and it is positive for irreversible process and equal to 0 for reversible process. So what is more, we'll discuss more about this entropy generation. We'll discuss more about this entropy generation. Entropy generation, whatever points I discussed, that can be noted down. So entropy generation, more about entropy generation. So what we discussed is entropy generation is there only during an irreversible process. So that is the important point. First point regarding this entropy generation is entropy generation within the system takes place only for internally irreversible process, and it is always positive, So you see, for internally reversible process, S then is always 0, entropy generation. You see, the more irreversible the process is, the quantity of S gen will be more. So because it depends upon path. The more irreversible a process means when the losses during a process are more, then the entropy, more entropy is generated during the process. More entropy is generated during the process. So now we are going to discuss about the principle of increase of entropy. Before that, we must know that whatever relation we have obtained, just what we obtained is delta S is equal to integral of del q by t plus s gen. And it's a different thing that for a reversible process this term will be 0, and for irreversible, for all of the process, the general equation is this: delta S is the change in entropy, and integral of del q by t is the entropy transfer, be it into or out of the system, and entropy generation is there, which is of course present only in case of irreversible process, and this term will be absent for internally reversible process. So you see, इंक्रीज ऑफ एंट्रोपी प्रिंसिपल के लिए हम ये जो रिलेशन है डेल्टा एस इज इक्वल टू साइक्लिक इंटेग्रल, सॉरी इंटेग्रल ऑफ डेल क्यू बाई टी, यू सी entropy is always before going into entropy principle or principle of increase of entropy, we know that we should understand these points. You see, isolated system क्या है, ये जो टर्म है अगर इन प्लेस ऑफ क्लोज्ड सिस्टम के लिए ये वैलिड है. इन केस ऑफ आइसोलेटेड सिस्टम, इन केस ऑफ isolated system, you see, in case of isolated system, what do you mean by isolated system? When there is no energy interaction as well as mass interaction. Since we are already discussing about the closed system, means there is no mass transfer, and if in case of a closed system no heat interaction takes place, then it is converted into heat, neither heat nor work interaction takes place, then it is converted into isolated system. And you know, there is no entropy transfer with work transfer. Entropy is transferred only with heat transfer. So in, if there is, if this the system is an isolated one, then this term will be eliminated, there will be no heat interaction terms. So this equation will reduce to s gen. Entropy generation, change in entropy will be equal to only the production of entropy or entropy generation. And if the process is reversible, then delta S will be 0. That's why reversible adiabatic process is isentropic. Delta S is equal to 0 means entropy is equal to constant, and that process is an isentropic process. So adiabatic होने से ही isolated हो सकता है ना. So if a process is closed and adiabatic, means that is isolated, no heat interaction is there, then only the process can be considered to be adiabatic. So this is the equation. But what is the entropy change? It will be the general equation. You see, increase of entropy, you see, this is an isolated system. Suppose if this system can be considered to consist of number of subsystems, this is suppose isolated system. So if this is subsystem 1, this is subsystem 2, this is subsystem 3, this is subsystem 4, and as n, suppose n number of subsystems are there, so this delta S isolated will be nothing but summation of delta S I, because entropy is an extensive property. Entropy is an extensive property. It depends upon the size or extent of the system. If the entropy change of this subsystem is 1, subsystem 1 is suppose delta S1, this is delta S2, delta S3, delta S4, so we can add all those change in entropies to find out the change in entropy of this combined isolated system, because the entropy is an extensive property. It depends upon the size, it depends upon the mass of the system. So suppose we can consider a system. Suppose this is our system and its immediate surroundings. We can consider the system and this surrounding. This is your surrounding, and this system and surrounding together constitute universe. We can consider this as universe, and this universe can be considered to be an isolated system. Isolated system. You see, how can this be approximated as a universe? By considering a large boundary and including system and its immediate surroundings within this, we can approximate this combination of system and surrounding as universe. And this universe is again a isolated system because this universe has not to interact in any way with the things external to this. So this whatever interaction can take place between these two subsystems, and this system and surroundings can be considered to be two subsystems of this universe, which is an isolated system. So if you calculate delta S of this universe or isolated system, this will nothing but equal to delta S system plus delta S surrounding. And from the previous equation, that is delta S of isolated system is nothing but equal to S gen, and there is no entropy transfer terms like integral of del Q by T. So that's why the equation is for isolated system, and if it is a reversible process, then this term will be 0 and this will be equal to 0. But general equation is delta S isolated will be greater than or equal to 0. Why? Because we have already discussed that entropy generation is always positive. Entropy generation is always positive, and it cannot be negative, and it can be 0 for reversible process. So that means this is greater than or equal to 0. Or I can say delta S universe, which is of course equal to entropy generation, is always greater than or equal to 0. That's why in limiting case it is equal to 0 when the process is reversible. But in actual processes, we know that whatever processes occur in nature actually are irreversible processes. And for irreversible process, delta S universe is greater than 0. And for reversible process, this is a limiting case, of course. Reversible process, delta S universe is equal to 0. And delta S universe cannot be, delta S universe is less than 0 means the process is impossible. If someone says that during a process I have calculated delta S system and delta S surrounding and added them and I have found a negative value, that is impossible. That is never possible. Process is always, the summation has to be either greater than or equal to 0. Greater than 0 for actual processes and equal to 0 for ideal processes, reversible processes. So that's mean entropy of universe is always increasing, That is also a concern not only for engineers but for philosophers, theologians, everyone. Because entropy means a measure of disorderness. In this universe, always the disorderness is on the increase. It's never going to decrease. So it has also physical significance and real life significance in everybody's life. If entropy is controlled, then life would be streamlined and everybody would be happy and everybody would lead a satisfying life only if entropy is controlled. So entropy or disorderness is not only of engineering significance but also it is important for real life problem also. So that means this principle is known as this principle, delta S universe greater than equal to 0. This principle is known as principle of entropy, principle of increase of entropy, principle of increase of entropy, or simply people say this principle of entropy, principle of entropy, or you can say entropy principle, entropy principle. So whatever processes occur in nature can be decided whether it is possible or not by calculating delta S universe. If during that process undergone by system, if delta S universe is calculated and found to be positive, means that process is feasible, and equal to 0 means that is an ideal case. But if delta S universe comes out to be negative, means that process is not possible. So that's why second law is called to be directional law, and it helps in determining the feasibility of process only by calculating delta S universe. How can we calculate delta S universe? We have to calculate first delta S of system. Whenever a process occurs, there must be a system and surrounding. So we will calculate change in entropy of system and then change in entropy of surrounding, and then add both of them. We will find out delta S universe, and that is also equal to the entropy generation. And entropy generation during the process, entropy generation is greater than 0 for irreversible process, equal to 0 for reversible process, but it can never be negative. But entropy change can be negative, entropy generation cannot be negative. Of course entropy generation is a path function, but entropy change is a point function, exact differential. This is ds is a exact differential. We have already discussed that entropy is a property, but entropy generation is a path function, inexact differential. ds gen if you calculate, then this will be an inexact differential. And so something more about this entropy principle is like this. What results we can derive from this entropy principle? This principle, you can say this entropy principle does not imply that does not imply that does not imply that entropy of a system entropy of a system can't decrease. You see, this confusion should not be created in your mind that during any process सिस्टम का एंट्रोपी डिक्रीज नहीं हो सकता है. ऐसा हो सकता है, एंट्रोपी ऑफ सिस्टम कैन डिक्रीज, बट इफ यू कैलकुलेट द एंट्रोपी ऑफ द टोटल यूनिवर्स, दैट इज सिस्टम प्लस सराउंडिंग, this can never be less than 0. Entropy change cannot be less than 0 as far as the summation of entropy of system and surrounding is concerned. Suppose entropy of system is decreased by 5 units. This is possible. Entropy of system can decrease. So how this comes out? Because you see, if entropy of system is decreased by 5 units, means entropy of surrounding will increase by suppose 6 units. That means altogether you will find that plus 1 unit of entropy will increase as far as the entropy change of universe is concerned. So whatever decrease in entropy of system takes place will be more than compensated by an increase in other areas in its proximity, that is in the immediate surroundings, so that the net change in entropy of the universe will be positive during any actual process, and in ideal cases that change will be zero, of course. So entropy of a individual system can decrease. There should not be any kind of confusion. That can increase, that can also decrease, and during a, so that is the principle of increase of entropy, one of the important facts. And another important thing is process occur. By applying this principle of entropy, we can determine the direction in which processes can occur. So processes can occur in certain direction only, not in every direction, in certain direction only. जैसे कि हीट ट्रांसफर होता है हाई टेम्परेचर से लो टेम्परेचर, रिवर्स कैनॉट हैपन स्पॉन्टेनियसली. सो दैट्स व्हाई that is only decided, direction is decided only by Sgen or delta S universe. The process can take place only if Sgen is greater than 0, that is actual process, and is equal to 0 means this is reversible process. And if you calculate Sgen to be negative in a process means that process is not feasible or that is impossible. And another important thing is, and process overall I can say process is feasible only when Sgen is greater than or equal to 0. Sgen is greater, less than 0 का कोई क्वेश्चन ही नहीं. Process is infeasible during that case when Sgen is less than 0 or delta S universe is greater than or equal to 0. Equal to 0 means that process is ideal case. So entropy, another important concept is that entropy is a non-conserved property. Non-conserved property. Unlike energy. Unlike energy. So you know energy conservation. So there is no principle of entropy conservation. During a process, entropy can increase. Of course, it can't decrease. But energy तो conserve होता है ना. Energy conservation principle is there. But there is, because energy is a conserved property and entropy is a non-conserved property, and that's why no conservation of entropy is, no conservation of entropy principle is there. No conservation of entropy principle is there. But energy conservation principle is there according to first law of thermodynamics. And from this relationship, delta S is equal to integral of del Q by T plus S gen. Or in differential form, you can write del Q by T or d cut Q by T, whatever you write, ds gen. These two are inexact differentials, but this is an exact differential. Exact differential, because the point function, entropy is point function. This is inexact and this is also inexact. So by using entropy principle, we can decide whether the process is feasible or not by calculating the entropy change of both system and surroundings and then adding them. If we find that value is positive means that process is feasible, and of course if that process is 0 means that is reversible. But if that value is negative, then that process is not feasible. And one important thing is, during any process undergone by a closed system, entropy change can be negative, both negative and positive, but entropy generation can only be positive or 0 during a reversible process. But entropy change of total universe cannot be negative during any kind of process, but change in entropy of the system only, because universe में system and surrounding होता है. If you calculate delta S of system only, that can be negative also during any kind of process. There is possibility that entropy of system can decrease, but at the same time entropy of surrounding will increase even in a more significant way, so that the net entropy of the universe will increase. So that's all. Thanks for watching.